I was going to talk about debugging. This is my free time, so let's spend it together. I love you guys, so I always spend my free time with you. Yeah, so first thing I want to talk about is what a bug actually is. You know, a bug is like a mistake in your code, something that didn't go how you intended. You know, that's not how you planned it to go, but then that's the result you're seeing. You're seeing something that you don't understand, something you don't want to see. That's a bug. Anytime you're getting results that are not your intended results, that's a bug. You know, it's like a mistake in your code. It could cause your program to behave wrongly or even crash entirely. There are different types of bugs that makes computer programs to behave different ways, in different ways that are not the intended way. Bugs are normal. They are not abnormal things. We are humans. Programmers are human beings, so we all have the tendency to make mistakes. Every programmer makes mistakes. I make mistakes. Senior engineers make mistakes. You would make mistakes. We are human beings. You know, the the bugs they're just like wrong instructions in a recipe. Wrong instructions that you've given to your code. And then you expect it to behave differently. You know, so that's what a bug is. It's like a mistake. It's a wrong instruction. you know and there are different types of bugs. You can have like syntax errors. When your code breaks the rules of the language you're writing. you know when you know don't follow the rule correctly, that's a syntax error. Okay, Jerry, you're saying you're here, you can hear clearly. I can keep going. When your code does not follow the rules of the language, that's a syntax error. In essence, let's say the language requires you to put a colon at the end, and then you're not doing that, you're missing semicolons. You're wrong. It's a syntax error. If you forget to use brackets, that's a syntax error. You misspell the name of a function, a basic function, you know in the code. Let's say you type function somehow, maybe you forget the C or something. All of those stuff, those are syntax errors. You They would make your code to not run, sometimes to crash entirely, sometimes to not produce the intended output. There are other types of errors. We have logical errors. Um uh the program can run. When you have the logical error, the program would actually run, but then it would not give you the result that you want. In my logical errors could be things like you not using the right formula that you want, uh, maybe using a wrong condition. Maybe you intend to equate something to another thing, and then you are doing something else. You know, double equals is different from equals. One is an equator. One equates what's on the left to the right. One assigns what's on the left, on the right to the left, and the other one equates. It checks if what's on the left is equal to what's on the right. So it depends on the language you're writing. You might be having these logical errors. It will make your code not to work as intended. Incorrect loop setup. You can set up your loop, and your loop is not correct the way you wrote it. It's just like I thought about for loops, and I told you guys that at first you initialize the variable, and then you give a condition before you increment. Some people might do it somehow wrong, put one before the other, or not, or miss something. That's a logical error. You get, you know your code will not return as intended. There are a lot. There are runtime errors. Yeah, there are runtime errors as well. Um, uh, the program will try for a runtime error. Your program will try to do something impossible. At runtime, errors generate. Let's say you do a loop that runs, and each time it runs for each, let's say, for each value of n, do something. Let's say divide the number by each value of n, and then the value of n goes down all the way to zero. You can't divide by zero, can you? You'd have an error right there. So at runtime, the error will not start at the beginning of the code when your loop starts. You'll be having everything fine and smooth till your code divides by zero. At that point, there are a lot of things that can actually happen. You can access a memory that does not exist in a C program. You know, that will throw an error as well. You can do an infinite recursion. In this assignment too, I did something like that. I made you to find something, to identify something that's uh, uh, that a loop that runs forever, and tell us why, or comment, make it not to run forever, something like that. So there are like a lot of things that you should know and do to uh, avoid getting these errors. See, errors are very common. Don't think that if you do it well, you won't be getting errors. I get errors too. Everybody will get errors. So we are all going to learn how to debug. We are all going to debug at some point in our code. The next thing that I should talk about is why we should, learn to debug. Why this class is very important. Um, Debugging is important. It makes your code works correctly, especially when you've done something and you are trying to come back to the correct flow, you know, of the algorithm that you want, you initialize in your brain. Like I usually used to say, programming does not start from the computer. Programming starts from the mind. Every single task that I've helped you guys solve, I did not solve it from the computer. I solved it from my mind first. You have to be a critical and logical thinker to be a software engineer. It's easier for you to do any other thing if you truly understand the values in software engineering that we are learning already, and we are still going to teach. There's a whole lot that I'm going to teach you guys to think like, for you to be able to build your final projects. Don't forget, final projects are really important. That's what will show that you're a graduate here. Everybody must build something, manage it. It must be profit oriented and legal as well. That's the criteria for me to approve a project for you. But for us to get to that extent, I need to train your mind to think critically and logically. And that's the reason for all of this tutorials that we are having on C. By the time I'm done with you, Python will be like the speed of light. The way you learn Python, you guys will be really fast. So we have to use C to understand all basic concepts as we are doing right now. You know, um, yeah. So I said debugging is really important. You need to get your code to a point where it works the way you want, and as well, it makes you a better thinker. Debugging makes you a better thinker, trust me. Because you have a problem. Most people get like frustrated. I know old me would have been frustrated when I see some kind of errors I see now. But because of the values that I've, learned over the years in software engineering, I'm no longer scared of getting an error. In fact, I want it. The more errors, the better. Because it makes me a better person. It makes me know that certain things that I'm doing are wrong, and I create the time to learn the correct values that I should have and implement each time I am on the computer. So you all should start getting comfortable debugging. You know, it helps me understand how the program really works. So I like it. Each time I have a problem, I don't get frustrated. I fix it. I sit down to want to understand what it is. It also, debugging also improves your problem solving skills. The first step to solving a problem is understanding it. You have to sit down, critically think about the workflow from when it was working correctly to the point where it stopped working, and you try to get to understand why it's no longer working the way that you intended, and then you you know start trying to fix it. Yeah. So how what's the right way to debug? What then is the right way to debug? I feel like um the first thing you should know is to not never get frustrated reading an error message. Comfortably read error messages. You need to clearly understand the problem to know where to start from to solve it, you know. So don't get frustrated when reading error messages. Be comfortable with error messages. That's the first step to solving debugging issues, you know. You have to read them because these messages include clues that would help you to getting distracted, clues that will help you to solve the problem, you know. The error messages will tell you where the problem emanated from and what kind of problem it is. That's how programming languages are built. Each time you have an error in your code, it's going to tell you what kind, if it's a syntax, a logic, you know, programming error or whatever. And then you can as well um, solve it. You can then know how to solve it from there. So the next thing is to know about debugging. The next thing, you need to learn to reproduce debug. This is how you understand it. You need to what actually produced this bug. You know, it's another level of programming. Once you're able to create the bug, trust me, you can solve it. You can solve the problem. Well, see, the fact that you know exactly why that bug is there and how to create it anytime that you want to create it, you know, you've created it once. Do you understand? You've the fact that you have this error in your code means that you've created a problem once. You need to learn to reproduce a bug so you know why it crashes, when it crashes, what you actually did to make it crash. You know, certain things that matters to for you to understand when trying to do this, especially when I say learn to reproduce the bug. You need to understand if it would always crash your system or if it crashes sometimes and it does not crash sometimes. You know, this is how you trace it and clearly understand where the problem is coming from. You know, so you know that's that about it. Another thing you need to do is you need to check your logic. Your logic is really important. Sometimes from your mind you've already created a bug, you know, from your the algorithm that you are creating in your head, in your mind, you have created the bug, you know. So you need to check, go back to your drawing board, you know, and check your logic. If your logic is good enough or not, you know, so you know what the problem actually is, if it's uh, you or if it's an error like a syntax error or something. Because many a times, um, beginner programmers tend to want to take the most difficult path to solve a problem. You know, they don't try to understand. We are going to learn about that. You know, there are times we are going to learn bit manipulation, big O notation in C. You're going to try to find out the easiest route to solve the problem. It's very important. You know, many a times there are certain problems that you can solve in programming with few lines of code. Beginners will think about it, and because it's software engineering, you want to make it so complicated. You want to make it so, you know, like something else. You know, it doesn't have to be too serious. It doesn't have to be too complicated. Life can be easy, you know, for even we software engineers. So you need to always, you know, each time there's a programming problem, um, there are usually more than one way to solve it. You know, different people would solve different problems in different ways. All the things that I've taught you, all the code that I've written, if we bring another engineer here, he's going to solve it in another different way because we don't think the same way, you know. So you need to learn how to how to solve a problem, what the fastest way is that it would take to solve your problem. It's like very important. These are concepts. I'm taking my time to talk to you, so you grow the right values, when writing code. These are things that you need. This is why you need mentorship. Is why you need mentorship to understand how to think. It's very important. So first thing you need to know is what you did and what you want to do. That's why you need to learn how to reproduce the code. You produced the bug already, so you've done it once. Now you know how to do it. What you just did that brings this error. Now, what you want to try to do is to learn how not to get this error. What part of your code actually brings the error? Go back to your strategy. Go back to your algorithm, your flow chart that you built in your mind, and you try to check if this was a logical error coming emanating from you, from your thought processes, your design, your initial plan for the workflow. That's another thing that you need to do. Then another very important thing that I just remembered now is you need to be printing out stuff. If you're writing a code, a C code, at every different block, at every different part of the code where you want to check if that's where your problem is emanating from, one very simple thing that we do to understand our work and know if that particular part is working is we just simply say something, echo out something to the screen. It's very important. Like it's the easiest way to do debugging right now. You just echo out something to the screen. um Another thing that is really important is fix one thing at a time. Don't think about two different problems, because while fixing one problem, you might go generate another one for yourself. So fix one problem at a time. Sometimes your code, you let's say you've written a lot of code, a lot of lines, and then you find out that you have a problem, and then you start debugging here and debugging there and debugging everywhere. It doesn't work that way. You have to fix one problem at a time. So in case you generate another problem, you'd know that you are generating this new problem from this block of code that you are trying to fix. So fix one thing at a time. Then I've already told you guys to be printing stuff to the screen, you know. Anyways, that's that for that. I think I've done a lot. I think I've said a lot. The most important thing, like the first thing that I think I said, which is the most important thing when it comes to debugging, is stay calm. Don't get frustrated. Never get frustrated. See, one thing about software engineering is the bigger the prospects, the bigger the challenges. You know, if you're faced with building a program that costs millions, it's for it to cost millions, it's obviously a big problem you're trying to solve. So you're going to obviously face difficult challenges. So you cannot get frustrated at the first challenge you're having, or the second, or the in fact, the only way you stay successful in this business is if you learn to stay calm. You have to learn to stay calm when you're seeing things that you don't understand. It's very important. That's the first rule in debugging. Stay calm. It's not a problem. Think step by step. You have to think critically. You have to think logically. You have to slow your mind and reason things one by one, not rush off the whole thing. You just see stuff and you're rushing off. You don't have time. It's difficult for you to think about it or something. You think critically one by one, and then you ask yourself, why is this happening the way it's happening? You do little block tests. All your little block of code, you test them one by one. you know and then you don't have to rush when debugging. And then if it gets frustrating because you've been doing this for a long time and you're not getting it right, you leave the whole thing and come back later. Where it's a problem is when you leave it and you don't come back to it at all. You know, you just leave it for a while, give yourself some break. And sometimes, trust me, the key to solving the most difficult problems I've had in software engineering is just taking a break from work. Because sometimes I've written a lot of code and my brain is fatigued, so I'm not able to think critically anymore because my mind cannot concentrate deeply on a particular issue anymore. So that's one of the biggest problems that I've had or I've solved. Yeah, sorry, I had to attend to some issues. So that's some of the biggest problems I've had to solve. You know, you you need to learn you need to learn to stay calm. You need to learn to understand that mistakes are they are necessary in programming. They are inevitable. They are things that you cannot do without. You have to make bugs. That's how you become a senior engineer. There's no becoming a senior engineer without having bugs, without having to fix bugs. That's not happening. That's not software engineering. Um, yeah, so that's that. Um, like I said, don't rush. And what else should I talk about that would help you guys? Uh, okay, I think I've talked about trying to solve two problems at once. You don't solve too many problems at once. Don't do that. Solve one problem at a time. And the next thing, um, where's this stuff? Sorry, I am multitasking seriously. My mind is everywhere. Like I have a lot in my mind. Yeah, where was I? Not reading error messages. I've said that before. Not reading error messages. You have to read error messages. You know. Another thing is assuming instead of testing. You know. Assuming instead of testing. You don't assume, you test. You know. Don't assume things. Always test them to ensure that assume that you have an error instead of testing it. Don't assume the type of error you have. Test. Always try. Put codes. Try to put print statements in your blocks of codes and all that, just to know where exactly your problem is emanating from. You know. Yeah. So I think that's that. That's enough. I've said like a whole lot. Um, Another thing that I've always been stressing in this class was you need to write clean and readable code. Very clean and readable code, because if you're not doing that, then you cannot debug. Debugging becomes a lot more difficult. Variable names need to be what they need to be they need to be meaningful names. The fact that you can call a value any name that you like does not mean that you create a name that does not make any sense. You have to create names that make sense. Create names that sound like what they represent. The names that you're creating need to sound like the value that they represent. So variable names need to make sense. It's very important for variable names to make sense. Very, very important. Uh yeah. So that's that. You need to write clean, readable code. Variable names need to make sense. And um, you need to use comments. I talk about this a lot. You need to use comments everywhere in your code. Inside the function, you need to write a comment about what the function does. At the beginning of your code, you need to talk about what the script you're writing should be doing. So anybody that's reading it knows what to think like. He knows if this script works in the back end, what it does in the back end, what part of the entire control flow this script controls. It's very important. These comments are really important, trust me. I cannot overemphasize it, especially when you're working with another person. you know you need comments a whole lot. And then be able to call a friend to help you debug. That's fine. You have a lot of peers, you should be able to call a friend. So yeah, that's a little bit of an overview of what debugging is. Trust me, debugging is not punishment from God to computer programmers. No, it is. It's healthy. Debugging is healthy. Sometimes you need to challenge your mind beyond the normal, beyond the usual. So it's very healthy. It expands your brain capacity because it's exercise for the brain. Okay, so debugging is really good. It's good for your mind. In fact, programmers will live long because of debugging. Trust me. Yes, I think that's my own theory that I have propounded. All programmers will live long because of debugging. Now, I know it's a very controversial issue, and I'll be having a lot of programmers complain about this stuff that I've said, but then medically, it's good for your mind. It stretches your brain capacity. So it's fine. Anyways, so that's what it is. Okay. So you need to learn how to think like the computer thinks to clearly write code and clearly, you know, debug and become a successful engineer. Yes. So having said that, I should um, open up what we are learning today. Let me switch my screen so you guys can see what I'm talking about. Yeah, I'm done looking at you guys. I should go to debugging. Yeah. Okay, so the program tells you where to store your work and all that. By the end of the assignment, you should be able to explain what debugging is. I think I've done a lot of justice to this stuff. Identify and fix common coding errors manually. Read and interpret compiler error messages. I think I talked about you being able to do that. Comfortably reading error messages is really important. And apply logical debugging using test files and all that. Okay, we will get here. I'm going to teach you guys unit testing at some point. Uh, so we are going to get there. Curriculum is all encompassing. Don't forget that. Um, yeah. So the first one here says test this function, positive or negative. I've written this function before for you. You know, yeah, I've written it before for you, so I know that the function, this particular function, the one that works, you have it because I've written it. That's why I said when somebody asked in the live comment saying, "Are you going to do this practically?" I've written it for you before. All you have to do is go back to what you've been taught. Yeah, so this is a main function, okay? That calls the main function calls this negative or positive, and then you have int here is it's been initialized and it's called zero, and yeah, you're just trying to find out what it is. So you should be able to write this function and make it work. It's very important. You should be able to write this. Oh, this is the wrong. Yeah, this is it. Debugging. Yeah, we are correct. So your code should be able to call this function correctly and make it work. So you have to find out. You have to stress your mind to find out why this code would not work like this expected output. It's very simple. All you need to do is create a file, throw this code in it. You would have a problem. You'd see an error message, you know, and then you try to understand why you are having this error message, and you know it's a very small thing, a very small thing. And the reason why I'm not going to write code on this to help you do it is because I have written this code for you before when we were learning functions, and I think if else, right? I think it was during if else, and then it still came up again during functions. It's still the same uh, uh, code. This particular function, you know it if you've been following up the class. I've written it correctly, so I don't think I should be writing it for you again. Yeah, so the next one here says like and comment. Sorry, did I say like and comment? Where is the instruction here? The instruction here is saying you should stop an infinite loop by commenting out the problematic line. In fact, looking at this already, I see the problem. Looking at this function here, this main function, its main uh, print infinite loop incoming, and then there's a loop. I already see the problem on it. I want your mind to grow. This is debugging. I cannot teach you debugging by allowing you, solving this problem for you. It's a very simple problem. This is just a loop. I've taught you about while loops. You look at it clearly and find out what's wrong in this function, in this main function. And then when you rewrite the main function correctly, you push it to your GitHub as expected, you know. The other one, this one, says, fix the function largest number and return the correct results for any three integers. So here, this function is collecting three integers, and there's a buggy code here. Um, this code has a problem. It's a buggy code. Run this code on your computer, you would see the problem. This is the fixed code as well. Go and read the two. See the difference between the buggy code and the fixed code. The correct code, this is the correct code, this is the buggy one. Run this one in your computer, and then run this one as well in your computer, and then find out what's the difference between the two of them. Why is this one wrong and why is this one correct? I knew that this could be a little bit demanding for you guys, so I wrote the fixed code as well as the buggy code. These other ones at the top, I know I've written the fixed code before for this positive and negative thing, and for this while loop is too simple. That's why I'm not giving you any fixed code for it. It's because it's very simple. I want your minds to critically, for you to sit down and look at it and understand the difference. All you have to do, create a file with the file name, and then you copy this code and you put it in the new file, and then you run it. You try to find out if you're able to, get the correct code. You can call this largest number. You create a main.c file that runs this code. You can put this code in this particular buggy code. You can put it in 2 dash largest number.c, and then you create a main file, a main.c file, just like this one here, in tag 0, just like this main.c file, this one here. It runs positive, negative, that. You do that for this code, you know, put it in a file, create a main file to run it, and then see the error that you have. Do the same thing for the fixed code and see if it works correctly, and then find out why. For this one, I'm going to give you a clue. The problems of this code are in the buggy code. They are in the logic, you know. Here, the things that we are checking, these uh, conditions, the if statements, they are wrong, you know. So go and look at it, compare it, find out why. Let your minds be working. Find out why this one, what's the difference between this one, and why this one is not bringing out the correct result, why this one is correct. Go and find out. Think about it. Know it. I just want you to know it. I'm trying to make the debugging a little easier. Even for the last question, leap year, I have the buggy code here for you to copy and go paste. And then I have the correct one as well. Go and read it and find out why it's different. I've already written the correct one. I've taught you how to run a C file. I've taught you how to create a function in another file. In the last class, when I came to teach about functions, I taught you how to create a function file and how to create a main.c file separately, how to use the main.c file to call the function file. I've taught you how to include headers, you know. Yeah, so I've taught you how to run a C program, and I've taught you what if statements are, how to write a function. I taught you guys how to write a function. The body of the functions would carry the loops and conditional statements that I taught you, if statements. Uh, okay, they would carry if statements, they would carry conditional statements, the if statements are conditional statements. They'll carry if statements, they'll carry loops. That's the word I was looking for. Okay, so you now know how to write a function, you know how to write if statements, you know how to build loops, you know how to run a C program, you know clearly uh, uh, how to call a main file, how to call another C program, like something, whatever script.c in a C main function file, and then how to write GCC to compile both files and save them in a new file that you want to save it in. I've taught you guys how to do all of that. So you have all that it takes to solve this problem. This problem is not difficult. I tried as much as possible to make it as easy as possible. In fact, I went further to create both the correct solution and the buggy ones, just so you read them. So have patience. That's what I want from you all now. I want you guys to have patience enough to solve these problems. They are little problems. They are very solvable. All right. having said all of this, do have a good rest of the day,